Sound, there is sound. Welcome everybody. We're doing AdCoder today. Maybe starting from what? The regular contest? I think this one. Also, I wonder if one day I should try again heuristic contests here. I used to like those. Okay, there's AdCoder regular contest 201, but which problems I want to solve? I don't remember much about the difficulty on AdCoder, so let's just try something. Hi MacArthur, hi everybody. Also, is everything okay? So are we live on Twitch? And with a proper title as well. And YouTube. Yep. Also, another thing is great thumbnail. Another thing, is there chat? Oh, there is chat. Okay, so I can scroll through. Okay, that's good. Hi Prism. Well, let's see how difficult those problems are. This is rated 500. After solving, I will maybe say how I think it compares to code versus problems. Upload your video with caption. I'm not sure it's possible for live streams. Yes, I am from Poland. Bank table out of frustration. Not sure. I'm sure I cursed before, but when not being able to solve a problem. In the year 2000 something, blah, blah, and writers, 3 types by difficulty, hard, medium, easy. And every writer has some number of proposals for each slot, hard, medium, easy. For division 1, we need hard and medium. For division 2, medium and easy. Okay. So for a contest, we want hard plus medium from one author, medium plus easy from one author, maybe the same one, maybe not. Is the font size okay, by the way? Thanks for good educational content on YouTube. Hope you'll never delete those videos. You're welcome, Akshay. I don't think I will delete. A bit larger would be nice. I wonder how it will behave. I think that's fine. Though I wish that they... can I do this? Oh yeah, that's great. I can hide the top stuff. Now that's good. Also, here's the link. AdCoder Grand Contest. I don't think I'm participating. I will try to do some Code Forces Division 1, but AdCoder Grand Contest, I think I never had much fun in those. It's really too hard. It's a waste of problems. Unless, of course, you absolve. No, I'm not using a Mac. I'm a Windows plus Linux guy. Okay. The number of authors, 200,000. So just want to restart the layout. Nope. go here, you go here. Okay. Oh, if it's not... Oh, I see. So when we see an author with some number of problems, let's say 7 hard, 10 medium, 8 easy, then we can use him in at most 7 contests of this type, 8 contests of this type, at most 10 in total. In particular, can I say that he will for sure be used for something? Well, it doesn't hurt, I think, to get this number down a little bit. So even if we prioritize, let's say, hard plus medium, let's say we want this author to provide a lot of hard plus medium pairs, then still that will be at most 7. So at least 3 pairs of this type will be used. Use 3 pairs, medium plus easy, because it doesn't hurt at all. After that, what remains is let's see this 7, 5. Now, using similar logic, if we want to prioritize medium plus easy, anyway, we can use 2 of those. So use 2 pairs of hard plus medium. It doesn't hurt because it doesn't decrease your possibility of how many medium plus easies you can do. And after that, we have this, which means I can now provide 5 pairs of any type, hard plus medium or medium plus easy. So use 5 any pairs. Is it always possible, or was it just a coincidence? Let's try more random data. 290. What can we say here? Well, oh, if the number of mediums is more than the sum of those, then we can as well limit it. And here for sure we will use 2 pairs easy plus medium and, sorry, hard plus medium, and 90 pairs easy plus medium, and that's it. There will be no of those pairs. And what if medium is small? What if, for example, we have 2, 7, 10? Then this we can decrease down to 7, I guess. We can have 5 pairs of this type. So 2 and 2, and then 2 pairs of any type. Okay. I think that's good. We just need to turn this into code. Bigger font size, please. I will not increase it over this. Annoying problems on code forces nowadays to combat cheaters. I don't see any alternative that organizers can apply. Where would you put yourself at math? I mean, tack out to in your question, let's say math master. I participated in math competitions. I don't have much university level math knowledge, but earlier I could participate in national and almost international contests and win some of them. Okay, so let's see if I can well, turn this into ifs. We n times do something, and we have the easy pairs or division 1 pairs, division 2 pairs, and any. We read how many hard, medium, and easy there are from this author. And I want to know how many for sure I can make pairs hard plus medium, because the easy will be wasted anyway. I can do it as long as medium doesn't drop below easy, I think. For example, if medium is 10 and easy is 8, then I can create two pairs of hard plus medium, and also change font. Can do this. So it's medium minus easy. That's medium minus easy, but of course I cannot make more pairs than what I'm doing. I'm pairing this up with hard. So minimum of hard, comma this. And maximize with 0, I guess, because you don't want to say that we make negative number of pairs. Hard decrease by that, M decrease by that, division 1 pairs increase by that. Now, same logic we will use for making those pairs. So if we have 10 medium and 8 hard, then 2 mediums we can spare for sure. Easy minus equal, M minus equal, division 2 plus equal. And finally, so if M is greater than something, we use that. And finally, we have arbitrary pairs. So I almost want to say this, any plus equal M, but I don't think that's entirely correct. Is it? Maybe there is some strange case where those other values were 0. Like if medium is 100, this is 0, this is, and this is 0, then that stuff did nothing. Let's see if this is 2. I guess maybe first we can do this. We will not use more. And now is it true that everything is equal? I'm not sure about that. But if so, then this does make sense. Well, H and E can be bigger, right? From the very beginning. But if I did this, because I will not use more, then maybe it's true. And if stuff so far is correct, which I can check by copying. I can run for the sample test. Well, the answer did not fail, so this is indeed true. Now that I computed number of pairs of every kind, every contest is made of 1 division 1 and 1 division 2, and then any I want to distribute evenly between those two. So what do I need to say? I think this is for sure. If I already have 7 contests of this type, 10 of that, then I have 7 full contests. And then remains is equal, I don't know, div1 plus div2 minus answer. One of those values was greater than the minimum, so this is what remains. Out of those, this is certain, and now with this I need to fill stuff. I need to decide what else I can do. So minimum of remains, comma, any. If I have, for example, 7 contests of div1 type and 100 to fill as an extra, then it's 7 full contests. Then any decrease by that. And this is how many you have left of any type. So pairs of hard plus medium or medium plus easy, that's flexible. And the answer finally should be increased by this over 2. Because we need 1 pair of hard medium and 1 medium easy. So 2 pairs will increase the answer by 1. And print the answer. I must say I did not enjoy this problem. Oh, and it's incorrect. After getting accepted, I'm going to look at the editorial. Maybe there is something interesting there. So something better than what I did. It seems that my answer is too big, which is a good news. I would not be happy with achieving or obtaining values smaller than the optimal one, because I would not know what is wrong and how I could improve it. Versus here, this is almost for sure like a simple mistake, doing something illegal, creating pairs that do not make any sense. So that many should not be possible. Don't look at the editorial. I was going to do it after getting accepted. Okay, so I'm doing something bad. Let's see. By minimizing, I for sure do not create the answer that is too big. Then let's also, just to make sure, assert that everything is positive or non-negative. So I take something from hard and medium and I make a division 1 out of it. I take something from easy and medium, I make a division 2 out of it. What remains, if I have 5 easy, 5 medium, 5 hards, it's any pair I can create out of that. Division 1 and division 2 I pair up. I can maybe rewrite this as something easier to understand. It's max minus min. So if I had 7 pairs of one type and 5 of the other, then there are 2 remaining of one type. Oh, now it works. So wait, what was wrong a moment ago? Does that overflow? How can that matter? Isn't it the same thing? Max minus min, isn't it equal to... Oh, it would need to be twice the answer if I want to do it that way. Right? Because here minimum is counted twice. Okay, got it. So this should work as well. Yep. But maybe I will leave it in this longer form. You see, I wasn't 100% sure about the formula. I just rewrote it to something else that I thought is equivalent, and apparently it's not. Well, I was lucky that I tried to change it this way. I could as well not see the mistake for another 5 minutes or more. Submit. Oh, what do we want to use? C++ 20. I think that's what I want to use. Okay, so I did not like the problem. Next time I see something like this, once I realize that it's a bunch of ifs and formulas like that, I will skip it, the full problem. And I'm sure that this can be done shorter, but I want to see a way that is actually safer. Like you cannot make a mistake that easily. Accept it. So editorial. What? That's some... I think this is some very nice explanation for a code that will be 5 lines long, but I wouldn't expect anybody to come up with this way of thinking. It's something about achievable number of division 1 and division 2 contests, creating a regular shape where if you compute some border points, you can compute what is there in between and what intersects y equals x line. I mean, I think just by looking at it, I get the idea of which way it goes. It's nice that this interpretation exists, but it's obvious for me, as also a problem setter in the past, that people will not solve it this way. So what they are doing is, there is a simple formula for sure. If we only want to maximize division 1 contests, so just from every author collect division 1 contests, also separately maximize the number of division 2 contests, and theoretically then you can combine both, and then hence minimum of x and y. Oh, there is y2. Y2 is something else. Oh, x and y. So x is the maximum number of division 1, y2 is maximum number of division 2. Hence we have minimum of those two counts. And then turns out that additionally you check one more value and that works. Okay. Magic, I'm sure I could understand it in 5 minutes, but I want to move on. Editorials are always like this in AdCoder. I look at other people's solutions mostly. You know, I often did use the AdCoder editorial, though it happened to me that if I wanted to actually understand it, it would take me an hour to solve a hard problem and fully understand what's going on. It's often some kind of magic. Okay, next. So similar difficulty. And I wonder then what it would be for code forces. So this would be like division 1a. I guess. It was easy to solve, to come up with a solution, but tricky to implement. And I think most people will produce code that is not far away from mine. And items with exponential weights, and there is some value. And you run knapsack. Values are big, so nothing can be simple dimension of DP. Okay. So we need to be able to do knapsack where the pairs weight, comma value. The first value is always a power of 2. So 1, maybe 100, 150, 277, 4, 200, 16, something. And then I'm sure we will go either from smallest weight to biggest or the other way around. It's hard for me to imagine something else. Now, among values like this, how many can I choose? Well, what matters is how many full 2s I will take. Right? It doesn't matter if I take, well, that there is the given weight. Let's say the given weight, the full capacity, is 1024. This is the knapsack size. If so, it doesn't matter if I take 1 or 2 of those values, because they sum up to the same multiple of 2. If you need in the future to pack it with even values, then first it doesn't matter if you pack it with 1 or 2 ones. And I think what we will do is dp of how many of those we used, where size of that is linear. Then we will move here and we will cut some stuff. We want to get amortized amortized linear time complexity. Or is it easier to go downwards? No, I think increasingly will be fine. So after this, I will have dp of 0, dp of 1, dp of 2, dp of 3. This is possible weight that is used so far. Before I move on to the weight 2 and then following powers of 2, I don't care which of those two values is taken as long as the total weight is even. So I can compress it to dp of 2, dp of 0, 2, and 4. The 3 can as well pretend to be a 4. Possibly I should also divide it by 2. This way I will have a vector. So divide by 2 while rounding up. Then this will be dp of 0, 0, 1, 2. But also the weight was divided by 2. Now what should happen if weight is odd? For example, weight is 15. If I have something like this, we have, after considering that, we have dp of 0, 1, 2, 3. That gets collapsed into dp of, both of those collapse to, let's say, 0, and those collapse to 1. But what does weight become? Weight becomes, let's think, 7. The one we used for 3, this got divided by 2. Yeah, I think this is how it goes. So always the total weight, when we move from considering items of weight 1 to considering items of weight 2, the total weight we should just divide by 2 to now pretend that those new items are of weight 1. And the parity of the total weight will affect how we round things. If it's even, then we round up. If it's odd, then we round down. The number of total states to consider will be small. That thing is easy. But now for transitions, we can have linear number of ones and then linear number of twos. I don't want to get quadratic time complexity. We can sort items of the same weight. We prioritize those with big value. If this problem was harder, I would believe that some complicated logic would be needed here. Like we need to think about some convex function, stuff like that. Okay, let's try to solve a problem of just weights 1 and 2. So what should I do if n is up to 200,000? The weight is from 1 to 2, integer only. Value of I is big, up to 10 to the power 9. The knapsack size is big, up to, well, infinity. Hi, Akshat. Yeah. Welcome, welcome. How do we solve this? If the weights are only 1, then this is trivial. After sorting, it will be some kind of prefix sums. Should I do the same for weight 2? Just kind of sort it? But then it will not apply correctly to this. Again, if this problem was harder in terms of the score, I would think about some convex properties, but it shouldn't be 500 problem. If we look at the previous one that I've just solved, it shouldn't be that difficult. Should I know the solution by now? Also, do you think it's a good idea for me during streams like this one to switch between problems? When practicing on my own, I would do it sometimes, because if you're stuck on a problem, I will write this down. During practice, it is okay to, well, try multiple problems and switch sometimes. Right? In particular, you don't want to quickly go to the editorial, and sometimes taking a step back and doing something else, it helps you later get fresh ideas for this problem. That being said, during a stream, I don't think it's that good of an idea to switch context that much. I wonder, an average viewer of my stream, how much focus that they have on what is happening here, and how often they will open the stream and close. I imagine for some of you, it's like half background stuff, and then switching problems is a very bad idea. Because I recall the next problem also is 500. No, it's 600. I don't like it as a problem that I would think about in the background. So no, let's stick to B. I noticed that today when doing theme CP, I couldn't do the second problem, but when I went back to it at the end, I could do it. Here we go. Yeah, it of course happens. No, the CP problems are often some kind of puzzles, and you need to come up with an idea. Sometimes it doesn't just happen because you spend enough time. It happens because you're lucky. Your brain, well, it got into that particular idea. And approaching it freshly, or approaching it again, might help with that. Let's try. How do I solve this other than separately sorting those with weight 1 and those with weight 2? Also, if I sort, well, then I would sort together and do some kind of 2 pointers. Or do I need to analyze what is convex here? I'm not that stuck yet. I didn't spend that much time here. Well, if weight 1 has values, let's say 3, 5, 6, 6, 10, 7, sorry, 11, and then weight 2, it has values, maybe I should sort this decreasingly. The weight equal to 2 has different values like this, 21, I don't know, 11, 9, 9. On purpose, I'm using odd values here to avoid ties, because I will mostly compare the value of what is value divided by the weight. And if there are ties, it's harder to think about it, usually. So to come up with a solution, I assume that there are no ties. The values are distinct. The fact that here those two values are the same actually doesn't matter too much. If this was 3 and this was 6, then this would matter because they have the same efficiency of using your weight. Weight 2 value 6 is equally good as weight 1 value 3. So I prefer to keep it separate. Okay. So generally you will prefer this, unless the total weight is odd. If the weight is, let's say that, then you can afford one of those for sure. Take 11, forget about it. Now weight is 1024, this is eaten. And you can take some number of those pairs and some pairs from here. When you take a pair, you will first eat this thing as a 16, then you will take this thing as a something, and then this pair as a 3. Then you have all of this available to you, and you sort all of this: 25, 21, 16, 11 and 11, 9, 9, 5 and 3. Those are values you can obtain by getting new and new pairs, and just in this order you apply prefix sums to know the total value you can collect, depending on your weight, depending on the W allowed. Okay. But instead of doing dp, actually let's not do those prefix minima. I'm going to modify it and just say that the values now are 25, 21, 16, 11 and so on. Those are values that you can take by or obtain by getting new pairs, getting new stuff with weight 2. Also the answer for sure is equal to 11. This is that single value, and we took that because of the parity of W. And then we move on to weight equal to 4. This is weight equal to 2. Right? So then we say weight equal to 4 has some values. Now, if the remaining value of uppercase W, the weight, is odd, then I for sure take one of those. Otherwise, I group those into pairs. I sort them together with those decreasingly, and I move on to the next bit in W. That seems correct. Okay, then this is what I will code. And then I would say that this is significantly more difficult than the previous problem. In the previous problem, it was obvious how to start, and it was obvious that you will eventually get a working solution. Here it's not. What do we read? Use uppercase. What do we have? X and Y. X is the weight, Y is the other thing, the value. This is up to 60. I will say values of this weight pushback value. For every level from 0 to 60 or to 59, I will save the values from the input. Eventually I need to sort them. And now for every bit, I will look at the current bit inside of uppercase W. I'll also have some answer to which I keep adding. Always the values that I had before I need to pair up. Let's call those old. Sort decreasingly. Oh, and the biggest one you need to take. So if W modulo 2 is equal 1, then answer plus equal alt of 0, unless it's empty, unless it is empty. Erase the first element. So it doesn't hurt to eat this guy. Anyway, we will divide then this by 2 because we will look at the next bit. Now we need to update by collecting those into pairs and then those, well, without pairs. TMP pushback. Alt of I plus alt of I plus 1. And for that to work, I will append a single 0. Okay. So that possibly the last element now sees the next one, which is a 0. Okay, we have this. Also, TMP obtains everything from values of this weight. Now sort. Well, we sort here. And maybe that's it. There is high chance that I should do something extra, but maybe we don't need to. Vector of int. Let's use long. Not perfect. Not perfect at all. What if I modify W to be a 1? Then immediately something will happen. But still we have a 0. We have here 4 items. The weight is 1. So this guy should be available. Why is he not? Values of 0 push back this big value, the 3. I think we need to first do this. No, maybe not. Maybe yes. Do this. Alt equals TMP. Oh, a moment ago I didn't even have that assignment. That's bad. Okay. 70 something. 70 something indeed. Then let's submit. I will now summarize the solution if I get accepted. So at the end, we didn't really have any DP here. Interesting. An knapsack problem without DP. Half of the tests. Accepted. Okay, solution summary. For that, do I want to draw? Maybe I do. Maybe not. Let's say that my explanation will be mainly an example, because still I think that explains it quite a lot. Imagine that I want to pack the total weight of 3. And I have some items with weight equal to 1, and some items with weight equal to 2. Among those, sorted decreasingly, we have a 17, we have 15, 10, 8, 8, 3, 2, 1. And among weight 2, also I have some stuff. Maybe I have a 24, and the others will not matter. But now, if there is weight 3, maybe I will take something of weight 2, but anyway, at least one item of weight 1 I can afford easily. It doesn't hurt me. So I take it. This 17 I take for sure, and I don't care about those values. Even if this was infinity, still taking that would leave me 1 unit of space in my backpack or knapsack. So this I take, and answer becomes 17. Generally, the W value is odd, so it allows me to take one item of weight 1. Then I forget about this item. From now on, what will remain is basically this. And for that, I can take either an item of weight 2 or 2 items of weight 1. What's optimal first take in terms of combining 2 items of weight 1? Well, I can take 15 plus 10, so I have an opportunity to take 25. If I take it, then I also have an opportunity to take 16. If I take it, then 5. If I take it, well, I can take this element and then 1 unit of space will be wasted. Still, I have dust. And now this becomes available for me, each of weight 2. Those are also of weight 2, so I can take it together and sort decreasingly. 25, 24, 23, 16, 10, 5, 5, 1, 1, 1. This is sequence of new stuff of weight 2. Some of this originally was weight 2. Some of this is combined pair of 2 items of weight 1. Now, if this instead of 3 was, it was something else, let's say this was 17. In order to make my code easy, what I'm doing now is I'm saying, okay, I took 1 unit of space already. I took that element for free, the 17. So from now on, W is, let's say, 16. And now to continue doing the same thing, I'm pretending that those are items of weight 1, and this uppercase W is an 8. And I will continue the process. Then next items, originally 4, but now I pretend it's 2. They had some values possible, and I combine that depending on the parity of W. Possibly I take the first item. Eventually, the uppercase W will become a 1 after dividing by 2 a few times, and then I just take the first item, which possibly by now means what is the best possible 8 values that I can take in total. The values with that sum up to 8. So it's something like this. That was binary knapsack task. I don't know why they don't show it in green here. Also, there is a tool, right, for AdCoder checklist. What's the website when you can input somebody's username and it will tell you? It will show you The table with problems solved. Stop stock. I think I meant something else. What's the guy's name? Kenkoru? Anybody remembers? Oh, sitecodeversus.com. Can you? Kenku with that many O's? Thank you, chat. In particular, thank you, Nasan Nguyen. Okay, that's exactly what I wanted. There we go. Oh, this is so sad. Well, I solved some ABCs. Let's see it for AdCoder Grant Contest. Well, I solved quite a few problems around AdCoder Grant Contest 25, 40. Actually, I solved everything here because this is my round, AdCoder Grant Contest 47. So I could just submit my codes. I once had a goal of solving everything. Now, if somebody paid me a lot of money, I would do it, but otherwise, it's so much work, especially if you want to understand your solutions. So I think I'm not doing AdCoder Grant Contest, but what about regular contests? I guess this will take some time to load because I'm doing the 201. Yeah, so this. What should my goal be? Your sound is so low. I mean, well, the simplest thing I can do is just increase the gain in OBS. Done. Now it's up a little bit. Because on my microphone, this is maximized. I mean, also in OBS the microphone is maximized, but I can add a special filter. I could also talk like this, but I don't think that's very convenient. What should my goal be? Also, do I prefer AdCoder or Codeforces for those streams? Oh, in particular, how many people participate in AdCoders nowadays? Standings. But I'm not sure what I should compare it to. The regular contest is like Division 1, right? I see here how many people with positive score. Well, there are 60 pages of what, 20 people with submissions. So 1,000 people got scores and another few hundred attempted. What about Codeforces numbers? Do we have Division 1 rounds anymore? We do. Unless it was unrated or something like that. It's downvoted, but I think it's not Okay. So is it fair to say that here 2000 people participated with a positive score? No, less than 1000. Okay, and what about nationalities? Say an average person is around here in the leaderboard. We have a lot of people from Japan, and they will generally, I don't think they will often watch my stream. Also, what time is it in Japan? 11 p.m. And there is Vietnam. I think there are people from Vietnam who watch me. In particular, I'm guessing by the second name that Nathan is from Vietnam. So it seems in terms of people who participate in contests, doing code forces will be better for my streams than doing AdCoder. Which does not mean that I should not do AdCoders at all, just maybe from time to time. Any thoughts about it, anybody? Akash says, what about going backwards from highest bit, greedily picking the highest value based on power of 2? Well, you don't know if maybe using smaller powers of 2 will give you a bigger sum of values. What if you're seeing something with weight 1024 and value 77, but later you will see that with weight 128 there's stuff with value 40, a lot of them. And actually you can combine 8 of them to create this. Right? So what does it mean that going from big values of big weights, we would greedily do something? You can remember that you have that opportunity. But then also you have those opportunities and you can combine them into 8 or into 4 and so on. This seems more complicated, but still possible. When solving this problem, I also thought about this trick. When you have knapsack with repetitions, for example, there is item with this weight, this value, and it appears some number of times. It has some number of copies. Let's say, I don't know, 5. There is a trick that if you have multiple copies of the same object, then you can take 2 of them and say that it's a combined new object. So weight equals 100, value equals 34, copies equals 1. And you took 2 of those to combine into that guy. You can take another 2 and combine into this. And actually you should stop here. The logic is as long as you have at least 3 copies of something, combine 2 of them into the bigger value. So it's like if you have coins of $5, or notes, whatever, $5, you can as well instead have coins of $5 and $10, and you will be able to make the same items out of it. You can pay $5, $10, or $15. Same logic here, same logic here. But if you had $5 and $5, you cannot say that you just have $10 because, well, actually you can also pay a single 5. So in short, I'm just saying that at the back of my head, I kept in mind similarity to of what I'm doing to this trick of knapsack with repetitions. Okay, let's continue. But from now on, if after a few minutes I'm not liking a problem, I will skip. For the easiest problems, I assume that it will not take me that much time anyway, so it doesn't hurt to do it. But now it is possible that I will spend an hour to actually solve a problem. Okay, we have string with A's and B's. We have set of those strings, and it's a good set if every AB string of length, of infinite length, has some element of X as a prefix. So you want to saturate the prefixes. For example, if you have strings AB, AA, and B, they will make up all possible prefixes. And you can have more. If you also have this, then this is still a good thing. Or if you make try out of it. If you make try out of this, well, there is some property, like you have some nodes that are terminal nodes and they cover all possible paths down. You're given distinct AB strings. For each k, find the number of subsets that are good sets. Okay, it's almost for sure a 3DP problem, where you need to think about this as a tree and do a bottom-up 3DP. Maybe not almost for sure, but this is my first idea. That is how we should think about it. In particular, either we use A, and then everything starting from A is covered, or you need to cover AA and AB. And you read from their DP. I think that's fine. Okay, and for every K, find the number of good sets. That seems tricky, because this would be an extra dimension that will make the whole thing quadratic. Oh wait, I misunderstood. I thought that we need to count subsets of every size, but actually we need to count subsets of every prefix of the input. So it's more like, if you know the answer for this, then you now add one more string and you need to know the new answer. So you need to insert this as well. Then I would say that it's still 3DP, where what this means is that we update some path from the root to this guy, actually from that guy up. Memorized one or bottom up for beginners? If you're doing competitive programming, you want to do iterative DP. For multiple reasons. I have a video for that even. If you're doing interviews and you only care about solving easy and medium DP problems and you don't have infinite amount of time to practice, then go for recursion and memorization. But if you have enough time to practice, you want to go for the iterative. So for beginners, if you just have very little time to practice and you want to be good in 1 week, I think use the recursive one with memorization. Okay, so here's the plan. And for this, I want to do a drawing. Now, generally, you don't want to build trees dynamically if you don't need to. What they are saying basically that when there is new string in the input, we need to use it and then print a new answer. Instead, I want to read first all the trees in order to make the try out of it. The full tree I want to build first because it's easier to make it as a static tree. This, for example, would mean, let's say there is A, B, and so on. This is called try. If you don't know what this is, then you will not understand the solution to this problem, sadly. And so on. So first I build the full thing. Then I activate strings one by one. For example, there might be new string AB in the input. I mean new. I go for the input again. I see the AB. I see the path made out of this. In particular, this is its terminal node, the last character here. And I want to update its DP. Now, what is the DP? Well, can I have repetitions? No, distinct. Number of subsets. DP of any node is what? If node is terminal, then what I can have is this node and everything below. The number of ways to achieve that is 2 at power the number of things below. Plus, there is also number of things on the left child times number of things on the right child. And else, if the node is not terminal, then I just have this. Okay, so DP of node is always DP of left times DP of right. Number of ways to make your left child good and right child good. So it would cover everything out there. Plus, it's 2 at power below, but only if node is terminal. So if this node is the end of one of the strings, then you can take this guy, and then below you do anything you want. Which means that I also need below, which is another DP, like subtree size. This is subtree size of this guy, our number of terminal nodes below. So I also need to update that. And always DP of the root will be the answer. Seems good. What was the previous task again? Binary knobs. Then I think if you have the knowledge, then this task, the prefix covering, is easier. You need the knowledge of tries, but coming up with a solution here is, in my opinion, trivial. An experienced competitor will not miss it, will not miss such a solution. It's straightforward in terms of you immediately go into that idea. Though you need to have the knowledge of that try stuff. No test cases, right? Yeah. There is input. And always when I read S, I want to make it into, or wait, do I need to actually? I think I can do it as I go, because in try it's extremely easy to add new nodes, to add new string. Yep, I don't see a reason why I would do it offline. So no, I just say repeat n times, or even while n minus minus. So just repeat, well, why do I want to do it? Let's leave n as it is. Repeat n times, and here we read the string. Well, n is unfortunate because I can later mistaken it with the length of the string. Maybe let's call it count or something like that. Uppercase n. No. What denotes number of strings but doesn't denote length of a single one. Let's say ends. Just to make sure that, no, this is length of a string even more. Count strings. Linux, I use Linux Ubuntu. Now I start in the root. For every character in S, it's either A or B. I don't know, type. If C is equal B, is it uppercase? Yes. If this is B, then this will be 1. Otherwise, it will be a 0. This is type of the... come on. Type of the child. And I will now go into, I don't know, child of node of this type. Unless it doesn't exist. So if doesn't exist, then it becomes like next plus plus. No connection. Internet is fine. I got a warning that the stream is dying. Is it fine? I think it's fine. I'm using Restream to stream to both YouTube and Twitch. Okay, seems fine. So just in particular, I couldn't see the chat on my second monitor. It's fine now, but was it not fine even for a few seconds? Was there any lag, any freeze? Total length is this. So this is the try thing. You have nodes, and let's remember the path. In particular, it includes the root, I guess. Okay, now I need to go through it backwards and update the stuff. So reverse. Can I do this, or does it not compile? Notice existing variable. No. Let's then... I'm not sure how bad of a coding style this is, but it's like I'm pretending that this is a function. It will be its own internal scope. I make a note here, but then here it's a separate thing. Okay, going backwards, I need to do the DP thing. DP of node is equal DP of one child. In particular, this might be 0. And if it's 0, then this should be treated as a 0. I think it will help me if the root is actually 1. Not 0. 0 will be something where DP value is always 0. I think that will be better. There is modulo, right? Yep. It has been working well for me. No disruptions were okay. Thank you. Mode is this. As for you don't need to start from scratch. And the advice for you will be, I guess, the same as for everybody. Solve problems. Try different difficulties. You will see what is proper for you and just go from there. Topics to learn to attempt division 2 problems. You need to know how to code. Then you can attempt division 2 problems. Hard problems in lead code. I think my median thinking time for a lead code hard problem is less than 1 minute. Because many of those are just standard. Don't know about the average. If this is terminal node, also here we need to say is terminal of. Terminal means that it's at the end of some string. It's terminal of node. Also, if this is the root, the next is 2. It's true. For now, I'm not using modulo. I will add it in a moment. Below should mean what is the number of things below. I think it's easier to compute number of things including this guy. So we'll no. Yes, -1 because you're terminal. Here we want to say below of node plus plus. This is subtree size, including yourself. Maybe let's just then call it subtree size. And also subtree size of this node is the sum of two children. Maybe let's make variables for the children. Plus. Okay, and always what we want to do is print dp of 1, right? The root. Okay, terminal. What else? dp. Well, dp is something I want to maintain. A lot of zeros. That's not good. Should I never mark something as terminal? What about this? Can you tell me what is dp of 0, dp of 1, dp of 2, dp of 3? Is everything 0 always? No, it's not. Which makes sense. So when I go to A immediately, its dp value is 1. This guy also is a 1. And then we should have this. Do we have children computed correctly? What is child of the root of 0 and what is child of the root of 1? So left and right children. 2 and 3, that's correct. And their dp values are non-zero. What is dp of node? It's number of ways to choose the terminal node, so the strings in this subtree, so that everything would be covered. For example, if inside of some subtree we have this node here, and in particular this is one of the terminal nodes, so it's end of some string, and also this guy, this one, or maybe this one, this one, this one. What options do you have? You can choose this one, and then everything is covered. But also instead of this guy, you can choose this, this, and that, and then also everything is covered. What does it mean, everything is covered? If you go from the root to anything here, you will go through one of the chosen nodes. So what is the number of ways to choose some of the nodes, some of the terminal nodes, so that there wouldn't be any gap. You couldn't go from the root to somewhere infinitely below without going through one of the chosen guys. Oh, thank you, Xenox. Yes, you're right. This should be 1. What I should have done after my change is this. I should have went with this root, then this root. I mean, it's always better not to require a comment. And then what you want here is dp of root. Now I guess that we want modulo operations. Including the power of 2. Log 2 of 0 is 1. I here computed an array with powers of 2. Alternative would be logarithmic methods to compute that. I mean, to avoid precomputation. Okay, problem solved. Now I will take a guess. Why error? Not a human. I will take a guess that if we look at the standings, then this problem for the top participants, this problem maybe was easier, meaning they spent less time than the previous one. Wrong answer. I wonder if it will be for just few tests. Oh, it's good that I'm using my power of 2. 2 of this. Okay, yeah. This is also wrong. I didn't even, after doing this fix, applying this, I thought it's such a trivial fix that I don't need to run again locally. Turns out that this way I don't even check if I computed the array correctly. So here goes like what, 3rd attempt, 4th? Should I try AdCoder contests? Yes, I think so. I don't think it's good to focus on any one platform, because platforms have their own taste or flavor of problems, and you don't want to only be good at this type. In particular for beginners, I think that AdCoder beginner contests are actually strictly better than Codeforces contests. Okay, problem solved. So now let's take a look at the standings, and my guess is for the top people, they didn't really spend more time on C than on B. This person solved in order, it seems, and we see 20 minutes and then 6. This person, started from F, but still this is 5 minutes and this a lot of minutes. Okay, so my theory doesn't work. 16 and 7 theory works. The order is all over the place, but let's say it's similar. Unless they tried A first, then B would be faster. Okay, here C took more time. C took more, no, after that 14 minutes, 5. B was faster. B was faster. Okay, my theory is not correct. Also, here do we see the difficulty? Not yet. I think this circle represents the difficulty, but the problems from this round have not loaded yet for the difficulty. It's not computed. Okay, so let's continue. Can you explain the transitions again? assuming that you understand the try thing, then here we go. No, not this. What was the? I forgot the shortcut. Control D? No. Okay, Control Alt D. I will actually talk about it more generally. Let's say it's a general tree. If you have a tree and you want to achieve something like this, count the number of ways to choose some nodes so that every path, let's say from root to a leaf, goes through at least one chosen node. This is not exactly the statement from today, from this add-color problem, but it's very similar. So let's say similar. Actually, we deal with binary tree. Actually, only there are some terminal nodes that we can choose. And it's not just to a leaf, but also to nodes that do not exist. Still, it's similar enough. Then, how do we solve this? Well, if you decide to choose the root, then the condition is already satisfied. Every path from root to a leaf goes through at least one chosen node. So what is the number of ways to choose nodes among the remaining ones? It's just 2 at power the number of those nodes. 2 at power size. It's 2 at power subtree of the root minus 1, because this one is already chosen. Like here it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 at power 10. Plus, there it's also possible that we do not go with the root. So the root is now not chosen. Then I need to choose something here, choose something here, choose something here, so that each of those subtrees would be covered. If this is child A, this is child B, and this is child C, then dp of A tells me how many ways there are to choose some nodes in this subtree so that the condition would be satisfied, that every path from the root to something here is covered by at least one chosen. So dp of A tells me that, times dp of B tells me the number of ways to choose that inside of the second, and dp of C inside of the third subtree. And that's it. This is the formula. In my code, I always had this, and this I added to the answer only if I could choose the root, because actually the statement basically provided the nodes that we can actually choose. So this I would apply only if the root is something that is allowed to be chosen. Also, this was not exactly subtree size, it was number of nodes below that we can choose. Why isn't dp of A called A of dp? Dp of A. Well, I would guess that it's because we read stuff from left to right, so this is easy. Yeah, friend zone. I guess I understand why you're asking that, but I'm not going to spend more time thinking about it. Okay, that was prefix covering. Match mod minimize. And now I need to keep in mind that I am allowed to skip problems if they are not cool. Is it worth grinding code forces? I mean, before the AI, why would you grind code forces? I would argue that if it's only for the rating, then it doesn't matter. Then always the answer was you shouldn't do it. No, I think most people, at least should, practice algorithms to be good at algorithms. Not to have a certificate on code forces, I'm good at algorithms. In particular, if you want a job, you will go through algorithmic problems that you need to be able to solve. The code forces rating will not help you with that. Your skills will. Given two sequences, A and B, and an integer m, elements of A can be rearranged. Find the minimum possible value of that. So we want to avoid big value of this. Always when they say find minimum value of maximum, I rearrange the order of words a little bit in my head. So we want to avoid big value of this. In particular, we can binary search the answer. So the question is, after binary searching some value k, can we permute elements so that a of I plus b of I modulo m was smaller than k for every I? That's the statement. Hi, cool dude. This is what we need to solve. And I'm not saying that binary search will be needed. Maybe it's some kind of sort and two pointers kind of thing. We'll see. Too many platforms for programming. Please suggest some. At coder.jp. If I came up with this problem, by the way, as a problem author, I wouldn't be sure that if it appeared before. It seems standard. I don't see a solution, but I'm just saying, feels standard. Yes, I do use Genie. I keep using Genie because it's very convenient. I have two buttons to compile, F9, F8, which do it with different flags. And so far, I didn't see software where I can achieve that so easily. To compile with debug mode and without it. That being said, Genie is not good for big projects. Not good at all. Yeah, it's minimal. I agree. Okay, let's say M is 10 because, or maybe 100. It's easy to think about round values like this. And now if values A and values B, if values A include, let's say, a 10, then in B you want something that is not 80 something. This would be very bad because 10 plus 85 modulo M is very close to 100. Instead you want something else, maybe 40. If you have here some values, let's go with M equals 10. If you have here some values, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for now, let's say. Then it seems reasonable to match it backwards like this. So those will sum up to 6 at most. And here match this with a 0, this with a 9 or less, 8, 7. This guarantees that every sum of two values, it doesn't exceed 6. So maybe after sorting A, what will happen with B is that we reverse some prefix and reverse the remaining thing. So that this would be below M and this would overflow M. I'm not 100% sure that just this style is optimal. Thanks for solving that D token removing cursive question. Oh, I still didn't take timestamps to post about it on Codeforces. But yeah, you're welcome. I still think that my explanation was so much better than the Codeforces editorial. Well, If we look at A0 in B, we can find the biggest value that added to A of 0 does not exceed K, or maybe smaller than K. We can then keep doing it, and eventually we will fail. Eventually we cannot find something like this. Then I'm guessing that from now on we should find something that overflows M. But can we do it in this order? I have no idea. So my current idea, for every AI, using binary search or something like that, set lower bound, find largest value in B such that A of I plus B of J smaller than K. If it exists, then use it, put it here. If it doesn't exist, then what you do instead is find largest value in B such that A of I plus B of J is smaller than K plus M, hoping that it overflows and the value modulo is smaller than K. Now I hope that doing this either in this order or maybe backwards is enough. Maybe also we should prioritize this first. I don't know. But I think that coding this is simple enough that I should try it. If this was an ICPC contest where you have 3 people but only 1 computer, I would now think more about it. I don't want to waste computer time, but in an individual competition, you have a lot of computer time. And I really think that solving this or implementing it is simple. Do we have test cases? Yes, we do. I wonder how much time it will take. Can I do it in 5 minutes, let's say? So overflows, no. Already half a minute passed. I'm not done reading the input. It's a read B, sort, let's say both, no, sort A. I think B we want to have in a multiset so that we could use lower bound. Now do binary search. Keep values smaller equal K, let's say. At the end we'll print the result of binary search. And we'll see if we succeed here. Now create a multiset out of B. For every element in A, what you do is try to find something such that x plus y doesn't exceed k. So y doesn't exceed k minus x as lower bound, no, upper bound, k minus x, and now you do minus minus. If this is not begin, then this is something that is smaller equal, and now erase it. else. You didn't manage to find it, so now you do the same thing. Copy paste usually means that I could use a function. Well, mod plus that. And here else, this is a fail. Break. No, fail by default is false. If fail, then you couldn't achieve this thing. So you couldn't keep it below that. So low is k plus 1. Else this. And additionally, you should here check that indeed x plus this modulo mod is smaller equal k. Else fail. Okay, well, took 3 minutes and a half. So I think we're good. So given such time to code, it's not a stupid strategy to implement. And here we go. First sample test failed. So I'm not optimal here. That's sad. We have the m equals 6 and the values are digits of pi. 1, 3, 4 versus 0, 1, 2. Mod is 6. So for this, if we try to keep it below, let's say 3, then 1 will be matched with 2. This will be matched with 0. And here we fail. No. Let's also try reversing A. Maybe it will help. So now sort decreasingly. No, just why not try? Maybe it will work. Well, it doesn't work for the last test. And I know I've read the 2 comments by Rohit, and I wonder if he generally asks a question of how to improve, or he is just trying to insult me. The first, let me make a screenshot of the comments. So if you just read the second comment of who is he a grandmaster, I, by the way, first read how is he a grandmaster, like commenting on how stupid my code is or something. But from this, I'm guessing you're asking how to become a grandmaster? Well, if it's who am I, then, well, you can check my profiles online. Coding like a muscle memory, do you have idea of full algorithm and type while you think, or you think and type both? There is some thinking while I code. Implementing doesn't take that much effort. Let's compare it to speaking, okay? Saying things out loud. So for me, coding, if it's not extremely complicated, is similar enough to speaking. And while you speak, you can think about what you're speaking. It helps a little bit to think in advance. Maybe sometimes you need to stop for a moment and think about what are optimal next few sentences. But it's not that coding itself will occupy 100% of my brain. Does that make sense? Do I not like these questions? Irates, if you're asking about that grandmaster thing, I just didn't understand it. It's not that I don't like it. I type what I think, not what I want, actually. Well, then the question is, are you making typos or not? Okay, one more thing that I can try, but this seems stupid, is to first do the modulo thing. Well, also, let's analyze this. Oops. Also, it took me now 8 minutes in total. Well, we did some speaking with the chat, so let's say 5 minutes I spent, possibly wasted. If I go decreasingly like this, then 4 cannot be matched with anything to keep below that. So you try to keep it below 10, so hence 4 matches with 2. Then this remains. You have 3 and 1. 3 will match with 0, 1 will match with 1. But is there a reason for this to be optimal? Also, new idea is we can maybe ternary search on the length of the prefix that we reverse. Oh, sorry, Irates, I didn't see your previous comment. I only saw the one about not liking. Do you mind if I ask if you can recommend a resource to learn Java Go languages? I mean, you as well, you can type a comment as can you recommend a resource on that? And my answer is I don't know resources for that. So by the way, the meaning of this question doesn't change if you just do this, right? Can you recommend? Actually, even for C++, which I know I don't have resources to recommend because I learned C++ and Pascal from some Polish websites a long time ago. Those websites don't even exist nowadays. I don't even know where I learned Python. Maybe Python I learned through the years, just knowing few extra commands every here and then. Well, I know Java, but how did I learn? Also, it was Googling stuff when necessary. Okay. Well, I'm tempted to now code this ternary search thing, but maybe it's better idea to think. Okay, let's visualize the problem. There is the sequence A sorted increasingly. There is a sequence B sorted increasingly. Everything from A, it can be matched to some prefix of B, and then it will be small enough. And it can be matched with some suffix. My dog is making noises. Not really suffix, some kind of range here, so that it overflows the modulo. Remember, the condition is that we want A of I plus B of j modulo mod to be smaller or equal k. That's the condition. Then for given I and for fixed modulo and fixed k, I think this is how it looks like, what we can match I with. I wonder if maybe we should, for first few elements, we should just try to combine it. Oh wait, I think I see a possible issue. if the first element I combined with something here, the second element I combined with something here as well, but let's say the third element is so big that it doesn't work with those guys, then instead those two, I should have matched them here, and it would be better, because from now on apparently I want to overflow everything, and it will be easier for me with big values, not with small values. Oh, but there is still that condition, so I'm not sure if bigger or smaller value is better. No. After, so is it true that those guys should be merged like that? Or is it possible that instead of something here, I want a smaller value? Also, is it true that I will merge things like this? Maybe it's not true. Let's say that this is not optimal for some reason. So let's say that some connection is too small. If it's too small, then this one should be combined with something bigger, but it will leave something from here to be combined with something smaller. So it's even worse. And I guess similar logic will be the other way around. So can I possibly match those with something bigger? How does it help? It helps because maybe even this is too much. Maybe it exceeds k modulo m. Let's think about actual values. 10, this is, I don't know, 7. If this is a 9, and this is 8, 9 as well, then maybe you don't want to combine it like that, because 9 plus 9, 18 modulo 10 is 8, and that's too much. Instead, you would prefer this guy to be combined here. But in my example, 9 then combined with something here, well, unless it's a 0. 0, no, it cannot be combined with 9. Can we discuss and recommend possible solutions? No. When I think about a solution, I don't want any spoilers, unless I ask for them explicitly. Able to solve lead code easy, medium, but cannot do hards. There is no... You can grab mediums, sort by difficulty or the percentage of solved or something like that, and try to solve the hardest mediums or the easiest hards. Because the cutoff between medium and hard is arbitrary, and it's not really that all the mediums are easier than all the hards. Please come live every day. If I was paid for it, I could do it, maybe not full time, because I would need to have stronger voice, but I will come live every day. I will do streams every day if it gave me money. If I do it for free, it will be not that frequent. I see a lot of possibilities of what we can do. What about this? Maybe ternary search was too big of a word. Maybe we need to search for how long prefix there is, such that I can match things like this and they will not exceed k without applying module. That's very simple binary search. Also leading to log squared total because I already binary searched k. Those maybe we can ternary search this length and actually think about the answer. So we want longest prefix here, and then we hope that this is good. When we, let's say for this suffix, longer suffix means smaller sums. In particular, the sum can drop below m. Those are longer suffix. So if we have longer this, values will be paired with stuff more to the left. Shorter suffix means bigger sums, and stuff can grow above m plus k. For this part, there is some range of available prefixes. Well, I can here search for, it will be more complicated, or maybe more than one binary search, but I can check first binary search how long the suffix needs to be at least so that the sums would be small enough, and then also binary search how long it can be at most so that the sums would be, well, opposite of what I just said. So I'm thinking now about 3 separate binary searches. Binary search longest prefix such that a of I plus b of j is smaller or equal k. Binary search longest suffix such that longest. What is wrong with me taking everything? The sums will be very small. So I want them to be at least mod. And binary search shortest suffix such that if I plus b of j. What is wrong about taking just very short suffix? The sum will be huge. I want this to not exceed mod plus k. And now this is range of available suffixes. I want to check if it's compatible with this, well, range of available prefixes. I want to check if they have an intersection. I'm sure that one of those binary searches can be avoided. Right? Because you're later checking if, let's say, this range intersects with, say, this range. After you find, this is easier to handle the more to the left you are. So what we can do is just find this and check if it satisfies everything. I don't need to check separately for this because it's not needed, and this. Just check if this is valid. What is that? That is longest suffix. So I think we only need to do this binary search. You find the longest suffix such that this is true. It will find me position saying, now this suffix needs to be combined like this. The remaining prefix also combine it internally, and just easily check if it satisfies all the properties, the prefix and suffix. It will automatically check for those conditions. So I think this is what we do. Can we sub to the channel? I don't think so. When I researched that few years ago, I didn't want to be a Twitch partner, so so you're not able to subscribe. In particular because of the ads. I would be forced to have ads on the Twitch stream, and it seems terrible during an educational stream for you to be disturbed by a few minutes or even 1 minute of ad. That seems very bad. If I can click it from time to time, it's also an annoyance for me. And it's hard for me to imagine a scenario where I cover stuff that is not easy. So it's actually hard competitive programming stuff where people pay me enough in like subscriptions or stuff like that for public streams where it's worth it compared to a job. More than 2 sections. Well, it's guaranteed, or you can make it happen by applying modulo. AI and BI are up to m, so the sum of 2 values does not exceed 2m. So either it's in range from 0 to k or just above that. Only single time you will overflow m. Okay, let's do this, which is, I'm copying that. Also this I will copy a wrong CPP. The binary search was fine. Do I need to sort? Well, I sort both. Here now, binary search. So it's internal second binary search. Also, it's possible that this suffix is empty. I will binary search the first element of that suffix. Suf low is 0, suf high is n. So now from here to the end, we reverse, and the remaining prefix we reverse. Here I combine a of I, let's say check, of a of I plus b of this. A of I with b of n minus 1 minus I minus suf. Right, this is distance from the beginning, so this distance I want from the end. Awk is true, check function. Apply the modulo. Oh, and you want if sum modulo mod is greater than k, then fail. Awk is false. Okay. No, I don't want to do such full check because that's not monotonic. What I wanted to do is just find this. So I'm not doing that. I'm only doing this, and I'm just checking if this is true. So if a of I plus this is smaller than mod, that's bad. It doesn't overflow. Awk is false, and optional break. If this is okay, then this suffix is good, and I want to find the longest, so try suffixes more to the left. Else shorter suffix. Okay, I think this binary search is done. And now what I have is I found the best available suffix, and I shouldn't have erased that code, but now I want to verify for this suffix. Let me Control Z a few times. Copy this. Paste it here. Sure, let's go with fail. By default, fail is false. And here, fail is true. here I verify for this particular suffix. The suffix being sufflow, possibly n itself. Does it work now? It works now, which does not mean much. Do you do any job? Not a full-time engineer job. Freelancing and mainly teaching algorithms. Preparing people for Olympiads, for interviews. Accept. Well, then here, from the very beginning, I should have thought more about it, and I think the visualization helps. Because without this slide, it would be very hard for me to solve the problem. This analysis with a drawing was helpful. In particular, for a moment, I thought that we need 3 binary searches, but if you visualize with ranges what they actually represent, that you will know. Like if, again, what they meant is I was going to binary search the end of some range starting at 0. I wanted to binary search this. Then I wanted to binary search the beginning of some other range, the end of this other range, and I wanted to check if those 2 ranges that we see have an intersection. If they have an intersection, though, this is in particular a point of intersection. It doesn't matter where this ends. It doesn't matter if this white range looks like this or maybe like that. It does not change the fact of a Boolean value of do they have a common point or not. And that common point, what it represented is what is the possible cutoff between reversed prefix and reversed suffix. So to simplify the code, we only binary search this point without knowing this, we only binary search that. But once we have it, there is a trivial often check if this is indeed a good point that satisfies all the conditions. It's in some way checking if we are inside this range and if we are on the left from this range, but it's an easy linear check. Other than that, I will not summarize the solution because it would take a lot of time. Well, that was... I'm not happy about my speed in this problem. It seems that I could have solved that in 10 minutes and it took me, well, half an hour. Oh, the stream is already 2 hours, 15 minutes. I want to solve more problems, but I think I have other things to do, sadly. My aim is generally that the division 2 streams will be 90 minutes and division 1 streams, like today, where I actually when I actually need to think about problems, is 2 hours. I think this is enough for me for today. Yes, Solaris. Prefix is up to k and suffix is supposed to be from m to m plus k. But I only binary search how long this suffix can be so that it would be greater equal m. And then I separately easily check if it indeed happens to be smaller than m plus k. If not, it means that in my first binary search, the one for k, I need to go to k that is easier to achieve. I wonder if there is something nice in the editorial. Yeah, they are describing single logarithm. Can we ternary search that cutoff? Oh, we can do something with 2 pointers technique. Sure. Yeah, I cannot in 1 minute understand how to achieve logarithm this way. It seems still similar to what I'm doing. How are we sure doing this is the optimal way to match them? For just like 2 minutes, I analyzed what happens otherwise. It was that analysis where I thought, can it possibly help that those two will be matched with stuff here and then somebody here wants to be with smaller? So I did some analysis there, and it was enough for me to convince myself that I think those guys as well can be matched here, instead of with something more to the right. Though I agree, this is not trivial, and it's part of a guessing game in solving problems if you want to do it fast, that you don't need to understand everything 100%. Also, during streams, I can tell you that I guess a little bit more because I'm also occupied with handling the stream, so speaking with the chat, sometimes checking if the stream is alive, and I need to talk talk out loud. So while during the contest I have a little bit of more brain power to actually think about a problem solution, and then I will more often really analyze something and convince myself before coding. Used to watch a few years back, now I'm already in the university. Nice. Okay, thank you everybody for watching. Today we solved ABCD from the regular contest 201. I think it would be nice to do everything, but well, I don't have time now. Maybe next time I will start from this task. Not sure. Oh, division 1, 2, 3. If this is harder version of the first task, then I'm guessing it will be a lot of casework, and so if so, it's ugly. This one maybe. Bounding. Okay, I want to read the geometry problem. Bounding boxes can still be geometry. Endpoints. Find the sum of areas. It's okay, it's not geometry, but it's summation, and I also like those kind of problems. Areas of bounding boxes. Well, I cannot solve it in 1 minute. Okay, I need to go. Thank you everybody again for watching. I want to solve this problem eventually, so I think in the next AdCoder stream I will solve this. Not sure if it will be from something that I start with, because it's not trivial, but I want to solve it. Okay, have a good day everybody, or a night. See you around tomorrow? Yes, I think so. Let's say see